In this lesson we're going to look at the electrolysis of various aqueous salt solutions, just to give us an idea of how to write the half equations that occur at each electrode. So what we're going to do is we're going to start with copper chloride, okay, and it's got a kind of deep bluish colour like that. So in this solution we're going to have 4 ions present. First of all we're going to have the ions from the salt, which is copper 2+ ion, and the chloride, Cl- ion, but we're also going to have the ions from the ionization of water, which will be H+ and OH-. We remind ourselves this is the negative cathode and this is the positive anode. That's right, that's the anode and the cathode. And the cations, that's the positive ions, will be attracted towards the cathode, the anions towards the anode. But which of these is going to be reduced at the cathode? We have to look at the reactivity series. We see that copper is actually below hydrogen in the reactivity series. So at this electrode, the ion of the least reactive element will be reduced. That's to say, the copper will be reduced because it is below hydrogen in the reactivity series. So we can write out the half equation for that. We can say we've got the cathode Cu2+ will pick up 2 electrons and form the copper atom. So you'll see deposited on this electrode a layer of copper as the copper ion is reduced. That means it gains an electron. Okay, and at the anode, well, the rules are that if the solution contains a halide, then the halogen gas will be released at the anode. So we're going to have chlorine gas bubbling off here. So we see that the chloride ion, that's Cl-, that loses an electron. So we write the arrow here and it forms Cl plus E-, and this atom of chlorine joins together with another atom of chlorine to form a diatomic molecule. So we mustn't forget that. We put a 2 there. That means we need to put a 2 here, and we have to balance the charge. We need to put a 2 here. Okay, so that's the half equation for the anode. All right, so we're going to have chlorine gas forming. Okay, so this time we'll have a look at sodium sulphate. Okay, and the formula for sodium sulphate is Na2SO4. So in this solution we're going to have the ions of the salt, that's going to be sodium, and the SO4 sulphate 2- ion, and again as before we have the hydrogen ions and the hydroxide ions from the ionization of water. Now in this case we look at the reactivity series to see which of these will be reduced at the cathode. Well, we find out that sodium is above hydrogen in the reactivity series, so it's the ion of the less reactive element that is reduced. So in this case hydrogen is going to be reduced at the cathode. So the hydrogen is going to come up to the cathode and it's going to pick up an electron. So we can write the half equation for the cathode. We take the H+, comes along, grabs an electron and forms the hydrogen atom. Again, this exists as a diatomic molecule in the atmosphere, so we've got to put a 2 here, and then to balance that we need to put a 2 here, and let's make a bit of space. Just to balance the charges we need to put a 2 there. So that's the half equation for the cathode in this case. And with respect to the anode, well, here we have a solution that doesn't contain a halide. So the rule is if the solution does not contain a halide, then the hydroxide ion will be oxidized at the anode. So here we have at the anode, the OH- ion will be oxidized. This will produce water and oxygen plus E-, and so we need to balance that. Then we're going to put a 2 here and a 4 here and a 4 here. That's the standard half equation for the oxidation of the hydroxide ion. It's probably worth you remembering that particular equation. Okay, so here we're going to get oxygen bubbling off, and on this electrode we're going to get hydrogen bubbling off. Just remind ourselves again here, hydrogen, the hydrogen ion is reduced, and here the OH minus ion is oxidized. Okay, let's have a look at another substance, for example, dilute sulphuric acid. Okay, so the formula for that is H2SO4. The dilute solution of this will consist of 3 ions effectively. In this particular case, it's a little bit simpler. We have the hydrogen plus ion, that's the only cation present in this solution. And then the anion from the acid will be SO4 2-, but we will also have ionization of water, which give us H plus and OH-. We have 3 ions present in this case, the H plus, OH-, and SO4 2-. So the ion that's reduced at the cathode is easy, it's hydrogen. There's no other possibility. So we can write at the cathode, again, the hydrogen ion picks up an electron, it's reduced to form a hydrogen atom. Again, we put a 2 there, a 2 there, and a 2 there for the half equation at the cathode. And then at the anode, again, this is a solution that does not contain a halide ion, therefore it will be the hydroxide ion that is oxidized at the anode. So we can write at the anode in the same equation. You're going to just remember this one off by heart, it's probably the best thing. 4OH minus H2O plus O2 plus 4E minus. So the electrolysis of dilute sulphuric acid will result in oxygen being liberated at the anode. We've got oxygen gas, O2, and hydrogen being liberated at the cathode.